Okay, so this is the second video. I'm going to try to cover problems 64, 70, and 74. If I don't get all the way, YouTube has a 10-minute limit, so if I don't get all the way through, I'll just make another video. So let's go ahead and let's start out with problem 64. And I think what probably was confusing for a lot of you, besides just figuring out the equations, was working with the scientific notation. So I'm going to try to go through some tips here on how to work with that. So the question tells us a 600 kilogram geosynchronous satellite has an orbital radius of 6.6 Earth radii. What gravitational force does Earth exert on the satellite? So again, you hear the word gravitational force, and instantly you should think this equation. When you hear the word force, think of this guy, okay? And it tells us what one of the masses is, right? So it doesn't matter which one we make M1 and M2, it's just both the objects. So one of the masses is going to be this 600 kilogram satellite. The second mass is going to be the mass of Earth, which you can actually get either in the back of the book or on page 84. On the very bottom of page 84, you'll see that it has the mass of Earth. And it actually ends up being 5.98 times 10 to the 24th kilograms. Okay? And then we know G, right? G is always the same value, it's just a constant. And R, it tells us that it's 6.6 times Earth's radius. And you can get Earth's radius from looking on page 85. So if you look at the bottom of page 85, you'll see that it's 6,370 kilometers. So 6,370 kilometers. We actually need to put this in meters. I actually didn't tell you about this before, and I don't think the book did either. So this is one of the reasons that I'm not taking off for this homework, and I just want you to kind of see how to work these problems. So you always need to have your units and distances in terms of meters in order to get the right units in the end. So we can write this as 6.6 times that many meters, because there's 1,000 meters in a kilometer. And so when you multiply that out, you get 42,042,000 meters. That is the distance between the two objects. Alright? So now it's just a matter of taking all these values and plugging them into this equation and working the problem. So let's go ahead and do that. So force equals G, which is 6.67 times 10 to the negative 11th, times M1, which is 600, times M2, which is 5.98 times 10 to the 24th, divided by R squared, and our R is this guy, so 42,042,000 squared. Alright? So one of the problems with this chapter, one of the reasons that it's really kind of more difficult than some of the other ones, is that you have these massive numbers, right? And so doing the computation on this can be kind of tricky. So I'm going to teach you kind of some tricks for dealing with this. If you have a scientific calculator, you can obviously just put these in. But let's assume for the moment that you don't. We know when we're multiplying things like this, we're allowed to rearrange these terms, right? So one of the things we can do is rearrange terms that don't have exponents and ones that do. So it ends up looking like this. You take the 6.67 from here, and you can move the 600 in front, and you can move this 5.98 in front. And then we can move these terms that have exponents back. So you can see we've grouped them in the front terms and the terms that have exponents. Okay? And then when we square this huge number down here, which means just multiplying it by itself, you end up getting 1.76753 times 10 to the 15th. Alright, so that's where we're at. So let's go ahead and multiply this first term here. 6.67 times 600 times 5.98. When you do that, you get 23,931.96. Alright, and that's going to be times the second term. Now how are you going to do this? Well, whenever you multiply exponents, you just add them. Okay? So 10 to the a times 10 to the b is just 10 to the a plus b. Alright? So over here we have 10 to the minus 11 times 10 to the 24th. Well, that's going to be 10 to the minus 11 plus 24. Right? And when you do that, 24 minus 11, you get 10 to the 13th. So we can put that over here, 10 to the 13th. And that's a very useful trick to kind of know dealing with exponents. And then we're dividing that by 1.76753 times 10 to the 15th. Now again, we can just do the division of these front terms and then divide these terms together, right? We're allowed to split those apart. So let's just divide 23,931.96 divided by 1.76753. When we do that, we get 13,539. Now for this, remember over here when we added them, or when we multiply them, you add. Well, you can imagine when you divide, you subtract. So if you have 10 to the a over 10 to the b, that's 10 to the a minus b. So when we have 10 to the 13th over 10 to the 15th, that's 10 to the 13 minus 15, which is equal to 10 to the negative 2. Alright? So 10 to the negative 2 is over here. And you can either leave your answer like that, or if you know how to do scientific notation, 10 to the negative 2 just means you move the decimal place 2 places to the left, and you end up with that as your answer. Alright? And again, I would have taken either one of these. You don't have to really, I don't expect you to know scientific notation. So if you just left it in this form, I would have accepted it. Or if you put it in this term, I would accept it. So you can see this is pretty in-depth. It's a lot of math, which I know several of you are not all that comfortable with. So this kind of a problem would probably only show up one time on a quiz, if at all. And it probably will one time. But again, I know it takes a long time to do these. I'll probably keep the numbers very nice. I won't do it between the earth and an object. I'll do it between like two objects that have very easy numbers to work with. But you should kind of go through this example and kind of figure out how I worked it, knowing these exponent properties over here, and just kind of get a feel for it. And if this is still confusing, then go ahead and ask me and give me a call or email me. And I'm almost at the 9-minute mark, so I'm going to go ahead and make another video for number 70 and 74. Thanks. Bye.